Hello and welcome to Vantage Technology webinar. Today we have a very interesting topic is data chaos to clarity. Basically we are going through the what is a RAG and how we are going to extract what is the way you can extract the data or information from unstructured data is. So that is very important. So you can use whether you can use it for any of your process or whether you can use it in your AI or LLM side. This data is very important. So let's jump on the today topic: data chaos to clarity, RAG to the harness unstructured data is. So before starting this session, let me introduce myself. My name is Rajneesh Kumar. I'm CTO of Vantage Technology. I have more than 28-year experience in IT side, and I'm doing AI and integration last more than 15 years. So let's jump onto this topic from data chaos to clarity is. So first let's understand is what is unstructured data is. Unstructured data which does not have any specific consistent format. It can store in cannot be stored in the typical relational databases. Like if you're coming to a relational database background, it doesn't store within your databases. It could be this unstructured data. It could be the PDF format or image file or audio file or video file or even web crawling information which is related with the HTML or any of those format is. So that is a very important, and all this information which is unstructured is also important as relational database information is. So that is whenever you are working any of your AI side or process side, application process, those information need to be extracted from the unstructured data and processed within your organization is. So now let's understand is what is a RAG. RAG is a retrieval-augmented generation. That is a RAG. Basically, RAG is transform the unstructured data into the searchable, which is you can use it the AI ready format by breaking content into the meaningful chunks. And also it generate the vector embedding that capture the semantic meaning is. That is where RAG is coming, and then that's where we are extracting those information from that one. In next slide, I'm going to go through how you can extract those information from the unstructured database, those data. So let's look into how RAG work on unstructured data is. So there is a two part over here. First is data preparation. Second is query processing is. So data preparation is basically we categorize, or we can do the two step format. How you can do the data preparation, because the data is scattered all over places and all different formats, and whenever you are extracting those information, it need to be proper sequence and also with the proper context. That is very important whenever you are working on the data. Then it makes sense for your AI model or any of your processes. So what is a chunking of the data in the data preparation for the RAG is. Chunking is the process of breaking down large document into a smaller, meaningful and semantically meaningful segment called chunk is. Here is you have to make sure that whenever you are working on the chunking is not very big, so that you will, whenever you are processing your data, it will take longer time, and it is not that short so that it will lost your context is. So let's understand is more deep into how this thing is work. So here I did the small building block is how this if you look for how the chaos of data look like over here is. Building block is all kind of data in all of the places is there is no sequence, there nothing is there, and then now you are extracting those information and then chunking this information and extracting those information. Let's see how it works. So now the chunk is always be fixed size. That is very important. Whenever you are working, chunk is always be fixed size. So whenever we are working on that chunk, so if you notice is all four chunks are in the same size. That is a very important whenever you're chunking in that one. Second is, it is a content aware chunking. So if you're working on the chunking side, that is makes sure that your this chunk is content aware. They know like what is the relation between one chunk to the second chunk, and second chunk to third chunk, and third chunk to the fourth chunk is. That is content aware. And also it is also semantic chunking. That is also that part of the semantic employ the natural language processing to group text based on the meaning and topic shifted. This approach often maximizes the relevance of search but add the computational overhead is. And now fourth one is recursive chunking is. So recursive chunking basically is start with the large chunk and repetitive breakdown then into the smaller unit is, and then keep finding what is the best fit for their requirement is or your requirement is. That is how it works is. So now let's jump on the why, how this chunk work and how they are correlated with. So whenever you're working, overlap is very important whenever you're working on this chunk is. Why this overlap is important? Because it maintains the context. So if you notice is, is one chunk is related with the second chunk, and second chunk is related with the third chunk, and third chunk is related with the fourth chunk. Here is they are maintaining the context of the whole chunk is, and then that's why whenever you search that chunk, it gives the context of that chunk is. Second is, whenever you are overlapping this chunk, it is very it improves the accuracy. That is a way you can make sure that all this information is correlated and accurate. If any of the chunk is unstructured, then there is no make sense for your data is. And third one is connect information. It also connect to your information between this chunk is whenever you're chunking and whenever you are overlapping that one. And then another last one is mitigates a splitting artifact. It acts as a buffer to mitigate the negative effect of splitting, such as cutting off the sentence or paragraph, which can confuse the model is. So that is also very important. Suppose that any of your sentence being chunked middle of the whole context, then whenever your model is going and searching and finding that information, it's very hard to figure out what information is saying is. That's why is overlap is very important whenever you are chunking those things, and also is a fixed size. So overlapping is necessary during the chunky to preserve context and continuity between text segment, preventing important information from being a split across the separate chunks. That is a way you can make sure that is work for your AI model is. So what is a strategy of this chunking is? So I already mentioned over there is, first is fixed size chunking. That is how it is. Second is content aware chunking, because it is giving the whole context of the data, not like a small set of data, and then whenever your model is going, it is very hard to figure out what exactly is going on with this chunk is. Third one is semantic chunking. Semantic chunking employs the natural language model, group text meaning, and topic shift. This approach maximizes the relevance of search but add computational overhead is. And last is recursive chunking. Basically start with a large chunk and iterative breakdown into the smaller unit. How chunk is impact AI model training is. Let's see is one by one. First is computational efficiency and scalability. Basically, training this data is broken into unified chunk from batches, which avoid the wasting computation on padding and allow for efficient parallel processing across the multiple GPU. That's where it impact of the AI model is. Second is memory management. If you have a very large chunk, it will consume all your memory, which is not good for you for your computation. It will take longer time to get that information. So you have to be efficient enough so that it will be not large and also you are not losing a context. That is a memory. That's how you can manage the memory of that through the chunk is. Third one is memory management. Third one is context learning. Is context learning basically is whenever one chunk is related with the one chunk context related with the second chunk, then you are basically the global context is hold that information is. So when global context fragmented during the chunking, still it is correlated with the each chunk, and that's where we are implementing whenever you are running the AI model is. And last but not least is data organization. Data organization chunking help organize large, complex, unstructured data into the meaningful, manageable segment, making easier AI algorithm to process information and recognize pattern more effectively. That is a last but not least how it helped for the data organization for this chunk model, chunking of this data. So now let's look into the indexing of chunk data, why it is important. So indexing chunk data involves converting each chunk data into a numerical representation, vector embedding, and storing into the vector database for efficient retrieval. That is very important. Now your data is saved. Now you have to identify where that information is being saved, how you can extract that information efficiently. That is important. So whenever you are starting those information, that is maintain what you have to keep maintain the context, accuracy, information, and all those which is related with your AI model is. That is very important whenever you are indexing and then extracting those information. So let's jump on the what are the different indexing methods. First is keyword indexing. Keyword indexing basically is you are storing your chunk based on the some keyword is which using across your organization. Suppose that if you are working on order management, any of your data, order PDF file, order number is your keyword, would be keyword. Whenever I'm searching for the any order or order number, your AI model immediately know like I'm talking about the what kind of chunk I'm looking into that. Same thing is vector indexing. Vector indexing is AI chunk are converted to the numerical representation called the embedding, use the embedding model. These vectors are stored in the vector database and used to perform rapid similar search with the user query embedding is. That is a vector indexing coming picture is. And last but not least is hybrid indexing. Hybrid indexing is basically is a combination of both keyword searching as well as vector indexing. Keyword indexing as well as vector indexing, both it work together. That is called the hybrid indexing. Now look into the data pattern. Key benefit of indexing is. So these are the things is important whenever you are indexing is balancing context of precision. It improves the retrieval relevance. Second is improved retrieval relevance, and now third one is metadata enrichment. So if you look for the how balancing context and precision work, is recursive chunking help find the optimum balance. The chunks are large enough to retain crucial context, but smaller enough to maintain the indexing efficiency, avoid overwhelming the AI model context. So you are not making a big chunk and you are not making a small chunk. So big chunk, it is take longer time to retrieve that information. A smaller chunk, you lose the context. That is important part. Second is improved retrieval relevances. By using recursive chunking, the stored chunks are more likely to contain the complete coherent idea rather than cut off the sentences. That is where it is this benefit of this chunking is whenever you are preparing for this data. And metadata is basically you are storing your information through the metadata or header information or markdown or code structure, which you can easily extract that information from the indexing. So query processing. So now next part is we have to look into the how query processing work. So these are the way you can query your data through the RAG is. First is query embedding. The user query is also converted to vector embedding using the same model to use for the source data. Second is retrieval. The query vector used to perform a similar search of a nearest neighbor search in the vector database to find the most semantic relevance data chunk is. That is where retrieval come in picture. Third one is augmentation. Augmentation, the most relevant retrieval chunk are then combined into the original user query to create a new augmented prompt. So basically you are retrieving to the most relevant chunk which is related with your augmented, which is augmented prompt is. And now last is generation. Generation is the augmented prompt is sent to the large language model. The LLM use this specific context to generate the fuel informed and accurate responses. That is how query processing works. So the two part is, first is storing the information, second is querying the information. That is the two parties, and RAG work both of the side is. Whenever you are storing the information, you have to make the chunk, you have to make the indexing. Same thing is whenever query processing work, it's couple of way you can do query embedding, retrieval, augmentation, and generation. So these are the things you can, and then whole process help to retrieve the information from your unstructured data. That's how RAG work for chaos of data into the proper information which help into the AI model is. So this is what our session is. If you have any question, feel free to reach out to us. This is our information. You can connect me on LinkedIn, and then feel free to reach out to me. Thank you very much for joining this session.